So in today's session, we are going to start one more topic that is integrity constraints in SQL. So what is integrity constraints? So basically integrity constraints are a kind of conditions which we can apply on the columns. So for example, if I take any table, in the table contains multiple columns, right? So in the columns means we can have some data in the columns. So at the time of insertion, data in the table, suppose if you want to validate some data. So for example, in my table, so let's say I have a table. So in this particular table, let's say I have salary column, right? So I need to insert all the data like employee name, salary, or employee name, first name, last name, and salary. All the records I need to insert one after another, right? So at the time of inserting the data into this particular table, I can validate this particular salary value should be greater than something, or I want to the salary column should be greater than, let's say, 5,000. So I want to apply this particular condition at the time of insertion of the data, and this particular column will allow us to put the value only greater than 5,000. So this is one example. Or suppose I want to store some other column. Let's say I have another column called as a city. So in this particular column, I want to store only specific cities. Let's say I have HYD and Delhi, or let's say Kolkata. So there are 3 cities are there. So I want to accept the data from the user. Only the cities are either Hyderabad or Delhi or Kolkata. So I can just enforce some rules on the particular column by using integrity constraints. Or suppose salary should be between something or some starting number or lower limit or upper limit. I can specify between 5,002 or 20,000. And whatever values I'm going to insert in this table should be fall under this particular range. So we can apply certain number of conditions or rules on the particular columns. And that is possible by using integrity constraints in SQL. So basically integrity constraints are used to apply certain rules on the columns in a table. So what are the integrity constraints we have? So SQL constraints are used to specify the rules for the data in a table, and constraints can be specified when the table is created with the create table statement or after the table is created. So at the time of creating the table itself, we have to specify what kind of constraint we are going to apply on that particular column. But even though if you have created your table already, we can also apply the constraint on the table level after creation of the tables, or before, after also we can do that. And what are the different constraints are there? So these constraints are basically part of the table definition. Okay, these constraints are part of the table definition. So at the time of table creation, we need to add these constraints along with the column data type sizes. Okay, so there are different type of constraints we have. So not null, unique, primary key, foreign key, check, and default. So these are the 6 type of constraints we have. So every constraint is having a different kind of a rule. So for example, when I say a column is a not null, so that column should not allow the null values from the user. So we cannot insert the null values into that particular column if I say a column is a not null constraint. Similarly, when I say a column is a unique constraint, so in that particular column, I cannot give the duplicate values. It will allow us to only put the unique data in that particular column. So that is unique constraint. And when I apply the primary key constraint, so it is basically a combination of not null as well as unique. The primary key is a combination of not null and unique. What does it mean is, when I say a column is a primary key, so that particular column will not allow you null values, and the values also should be unique. So it is not allowing any duplicate values. So this is primary key. So basically a combination of not null and unique. And there is another constraint, we have a foreign key. So this particular constraint will be used to establish the relation between the 2 tables. Okay, relation between the 2 tables. So we'll see how we can do this in examples. And next one is a check constraint. So check constraint ensures the whatever values we are inserting the column should be as per the condition. Like suppose we need to put certain condition. Let's say I have shown you some example here. In this particular column, salary column, I want user should enter only salaries between 5,000 to 20,000. So this is just a condition. So these kind of conditions we can apply on this particular column by using check constraint. At the time of inserting the data into the column, so check constraint will verify this condition is satisfying or not. If this condition is satisfying, then only it will allow the value into this particular column, or else it will throw an error. So that is another constraint. So that is check constraint. And default is another constraint. So default constraint, we can set some default value. Suppose I have a 3 columns in a table. I don't want to enter any value in some column. So by default, table itself will assign some value into the table inside the particular column. And if I don't specify any value, and table itself by default adds some value. So the default value we need to specify. Okay, so that is a default constraint. So these are the 6 types of constraints we have in SQL. Not null, unique, primary key, foreign key, check, and default. So these are very, very important. And especially these constraints are used by the designers, database designers. At the time of designing the databases, creation of the tables, establishing the relationship between the tables, they will more use integrated constraints. All right. So now we'll see one by one how we can apply these constraints. And when I apply these constraints on the table, so how we can insert the data, where exactly we use these constraints. Now we'll go for next. First one is not null constraint. So as I said, not null constraint will not accept any not null values into the column. So by default, whenever you're trying to insert the data into the table, suppose if you don't know some value, so you don't know the value of the column or value of the data, simply you can say null. So later you can update the data. But if I say any column is a not null, that particular column will not allow you to put null values. Okay. So let me show you one example here. So let me just create one table called student1. So go to your MySQL, and here currently I'm in HR database. I'm opening my SQL editor. So in MyDB, I have some tables are available. So no problem. Just let me create one more table here. Student1. So student1 is already there. So let me drop the table. So how to drop the table? Drop table student. So this command will drop the table. So now the table is dropped. So once it is dropped, so now I'm creating another table. So student1 table I have to drop, right? So let me execute, right? So now student1 table is dropped. So it is unknown means it is not there. So we need to go to MyDB, guys. Okay, use MyDB because this table is there in MyDB table, MyDB database. You can give uppercase letters or lowercase letters, no issues. Okay, let me just go to this database. Now it is pointing to MyDB. Now inside this we have a student1 table. I'm dropping the table. So let's drop table student1. So this command will drop the table from MyDB, which is already there. So now it is dropped. So now if I refresh here, we don't have the table. So now I'm creating this table. To create table student1, S number is number and which is not null. I'm writing in the different lines. So the student1 is my table and which contains the 3 columns, S number, S name, and marks. Now here what I'm saying is, along with the name of the column and data type and size, I'm also specifying the constraint. This is called integrity constraint. So not null is a integrity constraint. So with this particular constraint, I'm creating the table. So let me create this table, execute this, and it is created a new table. So once it is created this table, as I said, this column is specified with a not null. It should not allow the null values. But if I don't specify the not null constraint, it will allow the null values, because sometimes if we don't know the exact value, we can insert null value, but this time it will not allow any null values. Let's try to insert a few records. So let me just take 2 records here. When I say the first record, so here's insert into student1 values, and I have 3 columns, S number, S name, and marks. So this is my S number, S name, and the marks. So 3 values I'm assigning. So the data inserted successfully. So first row is properly inserted. So when I select this table, select start from student1, and when I execute this code, so it will give you the data. So 1 record is successfully inserted. Now in the second record, so I'm inserting this particular record. So in this particular record, instead of SID, because S number is not null, I specified the constraint not null for S number. So in the same place, I'm adding null value now. Because I say not null, so I'm still trying to enter null value inside the column. So when I enter this one, so this will give you an error. So when I see this error, column S number cannot be null. So column S number cannot be null. So this is the error it is throwing. So why it is throwing? Because internally we applied certain constraint on this particular column. That is not null column. So not null constraint. So because of this constraint, this one is not allowing us to put null value inside this particular column. Okay, so this is one kind of constraint. So when I say a column is a not null, we cannot insert null values into that particular column. So that is all about not null constraint. So we can also specify multiple columns also not null. Okay, single column or multiple columns. Now the next constraint is unique constraint. So unique is a constraint. This will not accept any duplicate values. Suppose if you have a normal column created, inside these columns, by default, it will accept duplicates. So we can also insert the same data again and again. But if I don't want to accept any duplicate values, that particular column we need to specify as unique constraint. So that particular column we have to specify as a unique constraint. Now let me show you one more example how we can use this unique constraint. So let me just again drop my table. Let me just remove this. So use my DB and again dropping my student one table. So again I will recreate this table. So let me just create this table. And one more thing is unique constraint can be created at the column level and table level. I'll show you both. Two different ways we can create constraints. Any constraint we can create in two different ways, column level and table level. So I'll show you first column level. So when I say create table student one, inside this S number integer data type and unique is my constraint, and S name is a normal column and marks is a column. So here instead of not null, I say unique here. So when a unique means this S number will not allow any duplicate values. Unique means this S number will not allow the duplicate values. Okay, so we can create table like this. So this is column level constraint. So this constraint is applied for this particular column. Now we can also apply the constraint at the table level. Table level means we are not going to apply constraint on the table. So table doesn't support any constraint. Only the columns support the constraint because the data is available always in the columns. But in other way, we can also create the constraint is once we specify all the columns like this. So create table student one, S number, integer, and S name. This another column and marks another column. And once you specify all the columns, and at the end, as a last one, we need to specify the unique of whichever column you are specifying as a unique. That column you have to specify here. So this is another way of creating the constraint on that particular column. So this is called a table level creation, and this is called as a column level creation. So if I specify the constraint immediately after column definition, that is a column level. And if you specify the constraint after completion of all the columns at the end, that is called table level creation. So here I say S number. And we can also add multiple columns by separating comma here. So that's the main advantage of unique. So if I say column level, I can specify suppose I have 10 columns and I wanted to specify unique constraint for 5 different columns. I need to go and apply the unique constraint for every column like this, right? But instead of doing multiple times, first to specify all the columns, whatever you have in the table, then write only once unique, and here I can specify S number, comma, let's say S name, comma, and you can add all number of columns. Whatever columns you are going to specify the unique keyword, unique constraint, you can add all those columns. So that's an advantage of table level creation. So table level creation of constraint. Okay. So either we can go for that way or this way. So both are exactly the same. So now I'm talking about the unique constraint. So what is the use of unique constraint is this particular column will not allow us the duplicate values. Okay, the value should be unique. Now let me execute this and it will create a table with this constraint. Now I will try to enter a duplicate value, then we will see what error it is giving. So I have created this constraint at the table level or column level. One of them we can follow. So now I'm trying to insert some data inside the table. Now observe this. So I have a table called integer. This is S number, S name, and the marks. Now observe this is a first record. So insert into student one values. So this is S number, S name, and marks, right? So perfectly right. So I'm executing this record, and now one row is inserted. So one row is successfully inserted. Now after that, let me just get the data. Select the start from student one, and when I execute this, you will get the one record. So currently we have one record. So this record we have inserted. Now what I will do is I will try to insert another record with the same S number. This is a duplication, right? Because S number is a unique as specified constraint. But if you say same value, if I try to pass again, so this will throw an error because this value is already available inside the S number. So this will not allow us to insert duplicate values. Now when I execute this command, this will throw an error. See this, what is error code is 10262, duplicate entry 101 for key S number. So this is an error. Duplicate entry 101 for key S number. So that means this value we have duplicated. This value is already there. So we have duplicated, so it is giving an error. Okay, so if I say a column is a unique, that column allows only unique values. It will not allow any duplicates. Okay, that's the main purpose of unique. And but can it allows the null values? Yes, it is also allows the null values. So for example, I'm inserting this record. I don't have the S number value. I don't know the S number value, which is unknown. So I'm not saying not null here, right? So only say unique. So I'm inserting this record. So this will also successfully inserted. So null is inserted. But again, I'm trying to add one more record with the same null. Will it accept or not? So if I say same number, same S number, I try to insert one more time, it is duplicated. So it is not allowed us. So this is incorrect. This is not allowed. This is not allowed because this is a duplication. But we already inserted this record with a null as S number. But I'm trying to insert one more null value, right? So let me execute and see. So I'm executing one more thing. So now it is accepted. So the condition is the behavior of unique is, we need to understand here is, when I say a column is a unique constraint, it will not allow any duplicates. So that rule is applicable for numbers and strings. And that is not applicable for nulls because null is not a number, it is not a string, not a value. It is just an unknown thing. We don't know exactly what it is. Okay. So null means it is accepted as a first record. And when I say again null second record, it is also accepted. So this is allowed. This is allowed. Okay, because we can have any number of nulls in a table. So unique constraint will allow more number of nulls, but a unique constraint will not allow the duplicate values in case of numbers as well as strings. So now when I execute this query, you will see the two null values here. You guys can easily see the table. See this is S number. There is one null and there is another null. So these are the, again, nulls is there. So nulls will accept it, but numbers we cannot accept it. If I want to store one more 101 record, it will not accept. Okay, so this is a behavior of unique constraint. So unique will allow only unique values, but in case of nulls, it will allow more nulls, more null values in a table. Okay, so that is about unique constraint. So unique constraint column can accept multiple nulls. Unique constraint column can accept multiple nulls. So this is about unique constraint. Now we'll see one more constraint, primary key. This is also very, very important constraint. So if you want to establish any relationship between the tables, we must specify one of the key, it should be primary key. Okay, because the entire row will be uniquely identified by using primary key. So the primary key is basically combination of unique plus not null constraint. So what is unique constraint? Unique constraint, it will not allow the duplicates. What is not null constraint? Not null constraint not allow any null values. So this combination of unique and not null. So that means primary key column will not allow any duplicate values and also null values. So primary key column will not allow any duplicate values and also null values. So even primary key constraint also can be created at the column level, specific to column at the a table level. So now I'll show you how to create a primary key column. Again, I'm dropping this table. Again, I will create. Fine. So I have dropped this column. Now I will create the same table again. This time I will say primary key. So S number is a primary key. So I can say primary key. So primary key is a not null and unique. So sometimes what happens is one column is also having more constraint. So one column can have more constraints. Suppose let us say S number column I am applying not null. So not null I need to apply, and also this should be unique. Also it should be unique. So two different constraint we have, right? So this is a unique, not null and unique. We put only one column. So this is not null is one constraint, unique is another constraint. So now on this column I have applied two constraints. One is not null constraint, the other one is unique constraint. So instead of passing these two constraints, we can specify a single constraint, that is a primary key, because the primary key is exactly equal to not null plus unique key. So not null means that column will not allow the null values. Unique means that column will not allow any duplicate values. So the combination of these two is a primary key. So instead of writing two constraints, I can simply say one key, that is called primary key. Okay, primary key constraint. So when I say S number is a primary key, so this key is a unique key, and it will not repeated or duplicates are not allowed, and nulls also not allowed. So that is all about primary key. So let me just create this table. So this is a column level definition. And if you want to create the table level, we have to write the same thing, but instead of specifying the primary key here, we have to specify the primary key after end of the last three columns. So once you created all three columns, here I'll say primary key of, and S number I'm specifying as a primary key. So this is how we need to specify. So this is the table level, and both are same. So this is a table level and this is a column level. So now let me execute this one, and this will create again student one table with a primary key. So now S number is a primary key which will not accept any nulls, and also it will not accept any duplicates. Now I have created one table with the primary key. So now let us try to insert some records here. So now this is the first record. So this is a comment in MySQL. Hyphen is just a comment. So these statements will be ignored at the runtime. Now we'll see the first record here. So in the first record, I'm saying 101, Arun, and 50. So I'm executing this record because currently I don't have any records in the table. So I'm executing this table's records. Now it is one row is affected. So that means this record is inserted successfully. Now again, if I try to execute the same record I have changed the name and marks, but S number is same. So when I say S number is same, primary key, right? So S number is a primary key, it will not allow the duplicates. So this should be invalid. So it should throw an error. So when I execute this query, so it is saying duplicate entry 101 for key primary. It is saying duplicate entry. That means this record is already there in the table. Now still I am trying to enter the same S number. So primary key is not allowing that. And also null, I am trying to insert a null. So null is also not allowed, right? So that's the definition of the primary key. It should not allow the duplicates, and also it should not allow the nulls. So now here I'm saying null here. I'm trying to insert null value in the S number column. Now this will also give you an error. So what is saying? Column S number cannot be null. Column S number cannot be null. So primary column cannot accept any duplicates, and also it should not accept any null values. So that is the behavior of primary column, right? So now primary key column. So primary key is the most important constraint. So if you want to establish any relationship between the one table to another table, we must specify at least one column as a primary key. Okay. So sometimes we can also apply primary key on combination of two columns. So that is called as a composite key. So let me just show you a simple example here. What is composite key here? Suppose I have, for example, I have S name. So S name I have, and S name is a grade, right? So I have another column is a grade, and I have a few more columns in the table, right? So S names are repeating. So let's say A, B, right? So I have X, again A is repeated. So I have repetitions are there, names. Even grades are repeating. Suppose grade is A here, and B here, B A here, and here B is here. So grades also repeating. But I could not find a single column is having a unique entries. But I need to specify I need to consider one of the column is a primary key. So how we can get it? So we can also apply the primary key on two columns. So for example, if I take columns, so these two columns as a combination. So S name is uppercase A, grade is A. So with this combination, there is no record available. If you see here, uppercase A, small case A. Do we have any record here? No. Right? This is a unique record. And similarly, if I say uppercase A, small case B is there. But this combination, there is no other record is available. And with this combination, there is no record is available. So combinedly, two columns we can consider as a primary key. And we can identify entire row with this combination. So when I apply primary key on two columns, that is called as a composite key. When I apply primary key on two columns, that is called composite key. Sometimes we could not, it is very difficult to find out a unique records in a single column. In that case, we need to take help of another column, and both the columns will combine together and apply the primary column for those columns. So let me show you one example. So here, so I have tried to apply the primary key column, and I try to enter the duplicates, so it is not allowed. And also I try to enter the null values, it is not allowed. And suppose we can create a primary key on combination of two columns called as a composite key. And composite key can be applied only at the table level. This is one more important point. Suppose I have another column. So let me just drop this table. And I will create S number, S name, marks is there. So S number. And here I'll say one more column, I'll say class. Class is equal to as an integer. I will say 3. And I'm not specifying any primary column. So if I say primary column here, that column only the primary column. Okay, so now I want to define the composite key. So that means combination of two S number and class. Combinedly, I need to create one primary key. So that we need to create only at the table level. So we cannot say primary column here. Here we cannot say primary column. And one more thing is, for one table, you will have only one primary key column. So one table can have only one primary key column, but other constraints are different. So suppose if you have a table which contains 10 different columns, every column can have multiple constraints. Suppose if you have not null constraint can apply in multiple columns. Even unique constraint can apply on multiple columns. But primary key constraint cannot be applied on multiple columns. So primary key is always should be only one column. And sometimes we can make two columns as one combination. So we cannot do like this. Suppose I'll say primary key. This is a primary key. And this is also, I'll say, primary key. So this is not allowed. Okay, so we cannot have more columns as a primary keys. Only for one table, one primary key should be there. And suppose if I want to make these two columns as a composite key, combinedly we can call it as a primary key. We should not specify here. We should be define this at the table level. That is called table level constraint. So here we need to specify primary key of S number, comma, class. So this is how we need to specify. So now S number and class combinedly we can call as one primary key for one table. Again, this is one primary key for one table, but this primary key will be created for two columns. But these are not separated. Combinedly, there is a primary key. But S number column contains the duplicates. Class contains the duplicates. But when I combine these two columns, should not have any duplicates. So for example, see here, I shown you. So uppercase A here, S name and grade is there. So with this combination, so in the same column, we have a duplicates. Here A is there, right? So here A is there. Just a moment. So here A is there. Here also A is there. Duplicates also there. Here also duplicates are there. But if I combine see these two columns, this is a unique record, and this is another unique record. So this is called as a composite key. Okay. So primary key and composite. Now let's go for foreign key. So this is another important constraint we have. So foreign key is basically used to link two or more tables, and especially primary key and foreign key is most important while establishing the relationship between the tables. Primary key and foreign key. Suppose I have two tables I want to combine these two tables. I want to establish the relationship between these two tables. So in both the tables, at least one column should be primary key. And then we can combine these tables. So to combine the tables, we have to use foreign key constraint. So a foreign key is a key used to link two tables together. A foreign key is field or collection of fields in one table that refers to the primary key in another table. So the table containing the foreign key is called as a child table, and the table containing the candidate key is called as a referenced or parent table. Now I'll show you a simple example you guys can easily understand. Suppose here I have an EMP table. So let's say I have a EMP table. So EMP table, I have multiple columns. Let's say employee ID, and I have employee name, employee ID, employee name, and employee salary, and department number. Let's say department number. And I have another table called department table. So DEPT. So this table contains the department ID and department name. So let's say department number, and this particular department number, what's the name of the department? So department name is also there here. Okay. Now I need to combine these two tables. So if you want to get all the data about employees, like including the department name, we need to combine these two tables. So we need to have some relationship between the tables. So what basis we need to relate these tables is, we need to identify what is the common column we have in this table. Common column. What is the common column? Department number is a common column, right? So even sometimes column names will be different, but the data type of column should be same. So I'm not saying column name should not be the same. Okay, column name can be anything. It will not be considered at the time of establishing the relation, but the data type of. So here I say department number. So here you have a department ID. So column name is different, but the data type is same. So here also it is integer, and here also it is integer. So that is also fine. Okay, so column name should be same. If column name is not same, that's fine. And column data type should be same. So to establish the connection between two tables. So now, so this particular column, so in particular EMP table, so normally ID will be the primary key. Okay, so for this particular column, I'm not specifying any key for that. But in this particular department table, this is a primary key. This is a primary key. Now, this particular table, this particular column is referring to this particular column in the EMP table. So this particular column, suppose in department number, I have a 20, 10, 20, 30. So these are the departments I have, right? So 10, 20, 30. So whatever employees details I'm entering in this table, all the employees belongs to either 10, 20, and 30, right? So one of these department IDs. So if I link these two columns from these two tables, so when I entering the new record in this employee table, if I enter some other department here, let's say 40 I'm entering, this will not allow us, because it will go and refer this particular table, whether the department 40 is available or not. If it is available, then it will enter the value here. Enter allows the value here. And if you say 30 here, then it will go and check 30 department ID is there or not. If it is there, then it will allow the user to enter the data. So we have to establish the connection between the two columns here. So this is possible by using foreign keys. Okay. So foreign key we have to use. So this is called as a parent table. This is called as a child table. Okay. So here, this particular column is referring here. So whenever you're entering the record in the employee table, it is checking whether department number is part of the department table or not. Because in the current organization, we have only these department IDs. So this department ID is exactly same for this, then it will allow the value, or else not allowed. And one more thing is, if I remove the record, if I try to remove the record from the department number table, okay, there are corresponding records are there in the employee table. So there are so many records which are there, which are depends on department 10, 20, 30. So if you want to remove this department number from the department table, it will not allow us, because there are some dependent records are available in the employee table with this department number. So we cannot directly remove the department number record here. If we still want to remove the department number, first of all, we need to remove all the record from employee table, whoever is having that particular department number, and then come back to the department table and we can remove this record. That is exactly relationship. Okay, so whenever you're entering the record in the employee table, it will go and check the department ID is there or not here. If it is there, then it will allow the values into a table. That's the one thing. Second thing is, with this department number, there are so many records are there. So if I remove the record from here, if I remove all the records which are related to 10 department, then only I can remove the record from the department table. Unless until we remove the record from the main table, employee table, I cannot remove the record here because there are dependent records are there in the employee table. So once we remove this one, all the records from any empty table, then only we can delete the department. So this is the basically achieved by using foreign key constraint. So now I'll show you how to apply these. And here this is called parent table, and this is called child table. So child table is always referring to the parent table. So once we deleted the records in the child table, then only we can delete the records in the parent table. So we cannot directly delete the records in the parent table, okay, because there are some dependencies are there. But still there is a chance to directly delete the parent table. Okay, if I remove the parent table value directly, the corresponding child records also automatically should be removed. So that facility also available, but by default it is not possible. So I will show you all the options. Now let's go and use foreign key constraint. So now I'm going to create two tables, guys. One is school table, the other one is library table. School table is a parent table and library is a child table. So always, so this particular table, child table is referring the parent table, right? So now parent table is having four columns or three columns: S number, S name, student number, student name, and the marks. And I define S number is a primary key. I define S number is a primary key. Fine. So now I have inserted some values into that. So in the parent table, I have some records 101, 102, 103. So what is the primary key here? S number is a primary key. Now in the child table, also I created a few columns: S number, and then only S number and book name. So there are two columns I created: S number and book name. So if you see S number integer 3, it is exactly the same as the same column in the parent table, right? So now I will refer this particular column into parent table. I need to join these two columns. I need to combine. I need to establish the connection between these two columns. So whenever I'm trying to insert the data in the child record, so this particular record S number should be referred in the parent table. If the parent table having that value, then the child table will allow us to put the value in the table. Okay, so let me just create these tables and I'll show you school table and a library table. Let's go to SQL Workbench. Now here in the my table, I already have school table and library table. So let me just drop those tables. Drop library, drop table, library. So this is a command, right? So then one more table is drop table school. Drop table school. This is another. So let me just drop it. So it is dropped, and also school is also dropped. Fine. So when I'm refreshing, we don't have a table. So now let me create library and school tables. So let me just copy this particular code. So I'm just creating some table for school table, and also I'll insert some records here. So create table school, and which contains three different columns: S number, S name, and marks. And I'll say S number is a primary key. So I define the primary key at the table level. You can also specify this primary key directly here at the column level. Okay, anything is fine. So now I'm creating this particular table. So now it is created. So this table contains three columns: S number, S name, and marks. Now I'll try to insert a few values into the table, like 101, 102, 103. I'm inserting these values. Now inserted. And after that, select the data from the school. Now we got three records: 101, 102, and 103. So these are the only three S numbers we have in this table. Now, based on this particular table, I will also create one more child table that is depends on this particular table. So that child table I will create now. So the child table is library table. See guys, so this is most important concept. So please observe. Okay, so now what I'm going to do is I'm creating the child table, guys. So library, create table library, and which is also contains two columns. S number is integer, and I will refer this S number from the parent table. And book name is another column here. Book underscore varchar and type of the data and size of the data. Now S number I want to refer in the parent table S number, that is from school table. So S number from library table should be referring to S number from the school table. So how we can establish the connection is we need to write a constraint like this: foreign key S number references, foreign key S number references. In school table column we need to specify. So foreign key S number references of school of S number. So this is a keyword which we need to use. Is foreign key of S number references. In which column it is should be referenced? This should be referenced by school table S number should be referenced. So this we have applied here. And then there is one more column called book name, which is varchar time. Now let me create this table. So now a table is created. So once you created this table, now observe guys. In the parent table, I have few records. So 101, 102, 103 records are there in the school table. That's your parent table. Now observe this guy. So this insert commands. So I'm trying to insert this record. Insert into library. So in which table I'm trying to insert records? In the child table. So in the child table, I'm trying to insert the records. What are those records? S number and book name. S number and book name I'm inserting. So at the time of inserting this record, so what library table will do is it will check whatever S number we are inserted here. That S number should also part of the parent table S number. It should exactly match the parent table S number. And in the parent table S number, we already have the 102 record. So then it will allow us to enter the data. So now I'm trying to enter the data here. Insert the data. Now it is allowed. So after inserting the data, you can again select the library table. Select a start from library. So when I execute this code, so it will give you one record is there. So 102 Java is successfully inserted in the table because this 102 record is there in the parent table. So whenever you are trying to insert a record in the library table, always it will check S number is having in the school S number column or not. So it will go and verify the school table S number. So that's the reason we specified this. I'm saying this is a foreign key which will references to school of S number. References to school table S number column. So in school table S number column is having that value, then only this value will be allowed. So now I'll try to insert some other value. Now we can see that. So let me take this one. So the second query. So now we can see here. So insert into library values 108C. 108C is a book name. So do we have a 108 record in the first table? We don't have. We have only 101, 102, 103. 108 we don't have. But still I'm trying to insert in the library table. So when I insert this record in the library table, so it is giving an error. See now, what is an error? Cannot add or update a child row, a foreign key constraint fails. Right? So what it is basically saying is, whenever I am entering the data in the child table, S number will go and refer the parent table S number. If that value is already there in the parent table S number, then this child table will allow us to insert the new record. Otherwise, it will not. So this is incorrect statement. It will not allow. Not allowed. Because 108 record is not there in the parent table. Right? So will it allow the null values? So let me execute one more statement. So insert into library values, I'll say null. I don't know exactly what is a SIS number, but I know the book number. But will it allow or not? So when I execute this, it will not also allow. So when I execute this, it is allowed. One row is affected. So that means null is also allowed. Why it is allowed? Because null is an unknown value. Null is an unknown value. Even the primary key also, primary key will not allow the nulls. Right? Primary key is not allow the nulls. But here, S number is a foreign key. It is not a primary key. It is just referring the values are there in the table or not, parent table or not. That's it. But the S number, I'm not saying S number contains only unique values. No. So in the child table S number, library table S number can also have the duplicates. But I'm not saying S number is a primary key, right? So it is allowing the duplicates, even nulls also. But at the time of allowing this, at the time of inserting the value, only it will check whether that value or number is present in the parent table or not. So even the null is also not allowed here because, okay, null is allowed because null is also accepted. So in the foreign key, null is also accepted. So even in the parent table, we don't have any nulls because null is not comparable value. Okay, null is an unknown value, we cannot comparable. It is just like here it is compared. 101, 102 is there or not in the parent table, it is compared. 108 is there in the parent table, also compared. It is not there, that's the reason it is giving an error. But in case of null, it will not go and compare this table because null is not a value. Okay, so nulls are also accepted. Nulls are accepted. So this is how we need to establish the connection between the table. So in this example, what we have understood is I have a school table. This is my school table. And here I have a SID column or S number column. And I have a child table. This is my child table. In the child table also I have a S number column. And there are multiple columns. So before entering the data or inserting, updating, deleting the data in the child table, that particular value, whatever we are inserting, it is referring to the another column in the another table. If this value, whatever we are inserting this value inside the table, if it is there in the parent table, and then it will allow us to get the value, or else it will throw an error. So this we have understood so far. If I establish the connection, now here this is just a primary key, but here this is a foreign key. So this is a foreign key and this is a primary key. But here in this column, S number column, we can have multiple records. Let's say 102 record I inserted. One more record also I can insert it like this. Here you can have duplicate because I not say this is a primary key column. But whenever I inserting the new record in this S number column should be referred to the primary key column on the parent table. The presence of the value should be there. That's the only thing it will verify. Okay, this is the first thing we have done, guys. Before inserting the value in the child table, this will refer the exact value is present in the parent table or not. So that we have understood. Now I'll show you the second scenario. So in the second scenario, I will try to remove the record from the child table. I'll try to remove the record from the child table. So will it accept or not? So we can directly remove the record from the child table. Okay, so child table records, we can directly remove it. But if you want to remove the record, suppose here, let me draw once again. Okay, let me just go here, guys. So what I'm going to do here is, let me just again pick the table, select star from school. Okay, so I have this much data I have. So this is the data currently I have in the school. So 101, 102, 103 is there. So in the library table, select a star from library. So select star from library table. So in the library table also we have a three records we have, but one record only having S number. So this 102 is also present in the parent table. If you execute the first one, 102 record is also there in the parent table. So let's say this is a parent table. Okay, this is your child table. Now observe this. This is another scenario. So in parent table, I have these many records, 101, 102, 103. In the child table, I have 102 and other records also there. So 102 record is there in the child table. Now what I want to do is, in the parent table, I want to remove the 102 record. So will it allow or not, first of all? So if I want to remove this 102 record from the parent table, it will not allow us. Why? Because there is a dependency record is there in the child table, that is a library table. So in the library table, 102 record is there. So until unless we have this record, we cannot directly delete the record from the parent table, right? If I try to delete the record, let me show you what error it will throw. So I'll just try to delete the record. So delete from school, delete from school, where So I'll say delete star from store. I can say simply delete from school where yes number is equal to 102. So this is perfect query, right? So delete from school table where S number is equal to 102. So when I execute this, so it is giving an error. What it is giving error here is cannot delete or update a parent row. A foreign key constraint fails. So what its meaning is this particular record we cannot delete directly from the parent. Why? Because the child table is having the corresponding record. So until unless the child table is having those records, we cannot delete the parent table record. Okay, so this is a general scenario, guys, in every table, right? So it is general scenario. So we have this parent table having some number, and there are so many records are there in my child table with this number. So all are referring to the same number. So if I delete this one, what about these records? They're all dependence records on this, right? So we cannot delete this record until unless we remove all the records. So if you want to still remove this record, first of all, we need to delete all the entries from the child table, whoever is referring to the same S number, and then come back to the parent table, then we can remove the record. Okay, that's the first scenario, guys. So here, this command, when I try to remove the record from the parent table directly, it is not allowing us, right? So now, if I remove the record from the child table, then it will allow us. So now in the library table, I'll remove the record from the child table now. So in the library table, I will have 101 or 102 record. So I will delete that. I'll say delete from library, where yes number is equal to 102. Now I'm deleting the first one or deleting this from the child table. So delete from library. Okay, so star is not required. So delete from library where S number is equal to 102. Now I'm trying to delete this record from the child table and removing this. Now successfully deleted. So if I see deleted, if I browse this particular table, I don't have that record. So now if I go and see the school table and still 102 is there, now we can remove this table because there is no dependency records in the library table. That is your child table. So we can directly delete the record from the parent table. Now I'm deleting this. Now it is successful. So now if you see the school table, we don't have 102 record. And in the child table also, we don't have 10 record because already earlier we have removed that record. Okay. So this is one more scenario, guys. In the second scenario, let me write here clearly. The first scenario, what I have done is, so if you try to suppose when you insert a record into child table, these are very important point, guys. So I'm just focusing on this. When you insert a record into a child table, okay, so the column will be referred in parent table. This we have seen as the first step. So whenever you're trying to insert a record in the child table, that record value is there in the parent table or not, it will verify. If it is available, then it will allow us, not allowed. That's the first point. Second point is, if you remove parent table record directly without deleting records from child table, it will not allowed. So if you remove parent table, if you try to remove the parent table records directly without deleting the record from the child table, without deleting child table means dependent records, then it is not allowed. So if you still want to allow, what we should do now is, third step, first of all, we need to delete record or delete dependent records from child table, then delete the record from parent table. Delete record from parent table. Okay, so these are the points, guys. Okay, now we have understood 3 points. First point is when you're trying to insert a record in a child table, it will also go and refer that value there in the parent table or not. If it is there, then it will allow us to insert the value. If it is not there in the parent table, it will not allow us. The second point is, if you try to remove the record from the parent table directly, it is not possible because there are some dependent records are there in the child table. So first we need to remove the child table records, and then we will able to remove the parent table records. So these 3 points we have understood. Now I'll show you one more important point. Even though the child table is having some records, I should also able to delete the parent record. So how it is possible? What I'm saying here is, in the previous point, what I have told is, if there are some dependent records in the child table, I cannot delete the parent table. Table record I cannot directly delete because there are some dependencies are there in the child table with the same record number, with the same S number. But what I'm saying now is, even though we have a child records available in the child table, I should able to delete the parent record. But when I remove the parent record, automatically child records also will be removed. How it is possible? So this is possible by using on cascade option. So there is one more concept called as on cascade option. I'm going to show you now. So foreign key constraint we have seen. Next one is on delete cascade. On delete cascade. So what this option will do is, as I said, the first point, this is completely opposite, guys. The first point what I'm saying is, if there are any dependency records are available in the child table, until unless we remove them, we cannot delete the parent record. But now I'm saying, by using on delete cascade option, even though we have a child class record, child table records, still we will able to delete the parent record. If you delete your parent record, child records also will be automatically deleted. So these things is happen by using on delete cascade option. Now I'll show you how to use this on delete cascade option. This is the exceptional case, guys. We don't do this normally. But very exceptional cases, we use on delete cascade option. If you still want to delete all the record from the child table, if you want to delete the record from the parent table, even though you have a child records, all of them I need to delete only one shot. Then we can go for on delete cascade option. So now I'll show you how to use this on delete cascade option. So normally we cannot delete the rows from the parent table unless we delete the corresponding row from a child table. That's a normal condition. But we can delete the rows from a parent table and corresponding child table rows as well at the same time by using on delete cascade option. On delete cascade option. Now I'll show you how to use this on delete cascade option. So I need to again create the tables, because on delete cascade option we need to specify at the table definition level. Okay, so currently I have a parent table already there. So I need to just modify the child table. So now at the time of creation, the child table, along with the constraint, we need to also add additional keyword that is called on delete cascade. This additional keyword which we need to add. Okay, and then that particular functionality works. Let me just create from the beginning. So let's go here. Again, deleting the both the tables. I'll just draw both the tables. Drop table school. And then drop table library. Okay, drop table school, drop library. So let me just drop both the things. And cannot drop school reference by foreign key constraint. So first we need to drop the child table, and then only it will allow us the dropping parent table, because there are some dependencies, right? So now I have dropped both the tables. So I don't have any tables. Now I'm going to create a fresh new tables. Let me just create the school table first. School integer, S number, S name, mark, same table, and S number is specified as a primary key. And I'm inserting some records in this table. So let me execute this one, insert statement, 101, 102, 103. So I'm inserting these three statements. Okay, so mydb.school is not exist. Let me just check it once again. Okay, so it is not properly created. Let me refresh. It's not created, guys. Let me create once again. So let me execute this code. So now it is created table. So refresh here, you can see the school table. Now I'll try to insert these records into the school table. Now execute these records. Now it is inserted. Now get the data by using select command. So now we have a 3 records, 101, 102, 103. And similarly, I will also create another child table. So this is my child table. So this is my child table. See now, so create library, and S number is this one, and this particular column S number, foreign key. Okay, foreign key is S number, which is, and one more thing guys, this we can also add here after completion of this, because this is just a table level definition. Okay, table level I have applied this. First of all, define all the columns whatever you want. At the end we can specify which column is the foreign key. So foreign key is S number, foreign key is S number, and which is referring to school of S number column. And now I have applied this particular keyword on delete cascade, on delete cascade. So at the time of table creation itself we have to apply this one. Okay, on delete cascade. But if I don't apply this keyword here, it will work in a normal way. So we cannot directly delete the parent table record until unless we remove the child table records. So that's the default behavior. But if you still want to remove record from the parent table and corresponding records in the child table, then we need to apply this particular on delete cascade option. Now let me create this table along with the on delete cascade option. So now it is created. So I will also insert few records. Now observe guys. So if I want to insert the records in this table, first of all, S number will go and refer in the parent table. So that we already discussed earlier. Right? So for example, if I am entering a record, insert a new record, 101 record I am entering. When I am inserting a 101 record in the library table, it will go and verify 101 record is there or not in the parent table. That's the default behavior. So let me execute this. So it is also inserted because 101 record is available. And 102 also available, so it is also successfully inserted. Now when I say select a star from library, select a star from library, so now this will give you 2 records. So now we have 101, 102. In the parent table we have 101, 102 and 103 also there, but in the child class we have child table we have only 101 and 102. So now there is a dependency, right? So in the parent table, so let's say this is your school table. So this is your school table. In the school table, 101 and 102 and 103 records are there. But in the library table, we have 101 record, 102 record. So these are dependencies there. Dependencies there, right? This is the parent table and this is your child table. Right. So now I already applied on delete cascade option, right? So now we'll try to, so because there are 2 dependence records in the child table, now I want to delete the record from the parent table directly. But normal behavior is not possible. But once you have applied on delete cascade option on that particular column, then it is possible. So here what I'm saying is, I am trying to delete the parent table record, even though I have a child table record is dependent. Okay, now we'll see what will happen. So currently 101 record is available in the parent table and also in my child table. Now let's try to delete the record from the parent table, not from the child table. Okay. So go to your parent table. Here school is a parent table. Now I am trying to delete from school, where S number is equal to 101. See this guys. In the first table, second table, parent and child table are having 101 record. Previously, what is the behavior we have seen is, so we cannot delete the parent record directly if there are any records in the child table, dependency records. That's the default behavior I'm saying. But this time, we still will able to delete the parent table record. Still, we have a dependency in the child record. So in the library table, we have 101 record. But I'm now deleting this record from the school table. Observe this. I'm deleting this record from the school table. Successfully deleted. Now, what is the effect of this one is, in the child table also automatically deletes that record. Now, if you browse a child table, 101 record is also removed here. Okay, this is the behavior. If you remove the record from the parent table, and in the child table, you can have n number of entries for that particular S number. All the entries will be deleted. Okay, so this is an option which is provided by on delete cascade option, and this we need to apply at the time of specifying the foreign key constraint. So this is the very easiest definition there. So just remember this one. Okay, so first to specify all the columns like S number, S name, S number, and then book name, and then finally specify the which column is a foreign key. Here S number is a foreign key, and which is references to school table S number, and additionally we have applied on delete cascade option here. Okay, so once we have used on delete cascade option, what is the behavior we have seen? So this behavior is changed now. Okay, so in the on delete cascade option, if you remove or if you delete record from parent table directly, and it will be removed, and also it will be deleted, and corresponding records will be also deleted from child table. So this is another important point, guys. Okay, this is a major use of on delete cascade option. So this is how we need to connect the tables by using constraints, and we can apply the rules on the table. So we have few more constraints, we will discuss them. So this is all about foreign key constraint, foreign key along with the on delete cascade option. So now we'll move on to the next one. So foreign key constraint at the table level also we can create. I just shown you foreign key at the table level means this one. First define all the columns like this, and then specify the foreign key. And as I said before, column name should not be the same, guys. Here S number I am saying, here roll number I am saying in this table. So in this table roll number is there, library table. In the school table S number is there. So column name can be different, but the data type should be different. Here also it should be int. Okay, so this we have to make sure. So this is all about on delete cascade. We already seen this. So next one is check constraint. So this is another type of constraint. So for how many constraints we discussed? Not null, and then we have discussed about unique constraint and primary constraint and foreign key constraint, foreign key with on delete cascade. So now I'm going to discuss about check constraints. So check constraint is used for allowing to user to enter specific values into columns. So whatever value are you going to insert into the table, it will check that value, and based on the certain condition it is matches, satisfies, then it is allowing the same record in the table or else not. So I will show you a few examples here. So let me just create this particular table, and let me just copy this code. So this is your again student table, guys. Let me have student is already there. Let me just remove the table, drop table student. Now I just drop this table. Now I don't have a student table here, right? So I don't have a student table. Now I'm freshly creating this table. So now observe this, guys. So I have just created one table, create table student, S number integer, S name is varchar, marks is integer. Okay, so till here just I specified the columns. Now what I want to do is at the runtime, whenever you're inserting the marks in the marks column, and marks should be between 15 to 100. So whatever values I'm going to insert in the marks column, those marks should be fall under between 50 and 100. So if I try to insert marks below the 50, it should throw some error. And even if you give the marks above 100, it should also give an error. So check constraint will be used here to apply certain condition. So here how I have written the condition is check is a constraint name and marks is my column name. So marks between 50 and 100. This is between is an operator. In SQL, if you want to specify the range, we have to use a between. So marks between 50 and 100. Marks between 50 and 100. We can also write the condition in different ways, guys. Check marks greater than 50 and again marks less than 100. So we can also write like this. Instead of between 50 and 100, we can also write like this. This is up to you, whichever way you want to write. But between is a very simplest way to specify the range. So instead of putting the 2 times column names, you can write simple one. So marks between 50 and 100. So this is also exactly the same. So now I just basically applied one condition on the marks column. So with this check constraint, I'm creating a student table now. So now I created a student table and I have applied the check constraint on the marks table. Now let us try to insert records one by one. So this is my first insert record. So insert into student table values, and 101 is S number, S name is Amit, and marks is 60. Now observe this. So when I say marks is 60, it is fall under 50, it will come between 50 and 100. So the condition is satisfied. So this column will allow us to put 60. So when I execute this statement, successfully inserted one record. Okay. Now I will try to insert one more record like this. So 60 is successfully inserted. So how we'll know that? We can just select the data. Select the star from student. Select the star from student. So when I execute this, it will give you one record successfully inserted. So marks column is having 60. Now I'm trying to insert this record. So in this record, I have 101 or let's say 102, Amit, or you can give some other name, or I'm not specified any other constant. You can also give duplicates, no issues. Now this time I'm saying marks is 45. But what is the rule I have applied here? Check constraint. Marks should between 50 and 100. But 45 is a less than 50. So this condition will not match. So this statement will go through an error. So let me execute this statement. Now we can see what is error it's giving. Check constraint student check 1 is violated. So check constraint is violated because this particular data, whatever we are inserting, is not exactly satisfying this condition. So that's the reason this is invalid. This is invalid. Now we'll see some other conditions. So this one. So this time I say marks is 105. Is more than 100. But what is our condition? It should fall under 50 and 100. So 105 is more than 100. So this is also invalid statement. So when I execute this query, it will also show check constraint is violated. So this is also invalid statement. This is also invalid statement. So check constraint will be used like this. If you want to apply certain condition on the particular column, at the time of insertion, user should allow only specific values. If you want to restrict the user to enter specific values, we can add check constraint to that particular column. Okay. So this is an example, guys. So I will show you one more example for check constraint. So let me just go through this one. So this time I'm creating one more table called location. So let's say location table. Okay, so location is my table name. So in this table, I have few columns. Let's say city, country, and pin code. City column, pin, country code, and country and pin code. Fine. So now I want to allow the user to enter only 3 cities, guys. Only 3 cities. Other than these 3 cities, if a user enters some other city value, I should not allow the user to enter the city value. So I can apply the check constraint again here. So how I have applied check constraint is create table location city varchar. So once you created the column, check is my name of the constraint. Here we need to put the condition. How I have created this condition is city is my column name. In is the operator, right? So city should be either Hyderabad or Chennai or Delhi. So one of them should be matched, and then only that particular city will be allowed. And user is entering other than these cities, it will not allow that value. Okay, so city column will not allow that value if user is provided other than these 3 cities. So I can also apply the condition like this. So this is just a condition, guys. You can apply. So not in, between, less than, greater than, all kinds of operators, you can use it here. So this is a check constraint. Now let me create this table. So location. So I have just created one location table. Refresh here. So now I got the location table here. So now let's try to insert a different values. So let's see this particular statement. Insert into location values, and here first value is city. I'm entering the city, then country, and then pin number. Okay, so this record is valid because this particular value, city value, is exactly matching this record. So one of the city, it is matches with one of the city here in the checklist. So this statement will successfully will execute. So inserted a record. So when I say select a star from location, so this will give you exactly a record. So one record is successfully inserted in the city column. Now I'll try to insert one more record. And now this particular city is not there in my list. So Hyderabad, Chennai and Delhi, I have given only 3 cities. Now this particular city is not there in this list. So now the condition is not satisfied. So when I execute this particular statement, this will also give you, this is location table, guys. Okay, location. Now execute this statement. This will also give you check constraint violation error. So check constraint is violated. So this city is not part of this list. Right. So this is another way of putting the check constraint. And suppose if I add one more statement here, select insert into location table values, Delhi, India and pin code number. Delhi is part of this list. Delhi is a part of this list. So this will allow us. So Delhi is successfully inserted. Now when I execute this query, currently we have only 2 records. So we have enforced some rules on the particular column, which will not allow other than these cities, other than these 3 cities. Okay, so these kind of conditions we can apply on the columns by using check constraint. Okay, so this is another type of constraint. It's called as check constraint. So we can enforce the rules on the table column, and these constraints we need to apply at the time of creation of the tables. Now we'll go for another last constraint, that is your default constraint. Now what is use of default constraint? Suppose I have some table, and every time I may not insert all the values in a table. Some columns I may miss. So sometimes I may miss any column data. Our table by default inserts some default value. So what could be the default value which we need to specify at the time of table definition? So let me just create one table called orders table. So let me just create this table. Let's go to your fine. So here I am just creating one table called orders table. So order ID, order number, 2 columns I have, and order date, guys. Order date we are not going to enter every time, right? So whenever I entering the order details, automatically the date column should be updated without the user entering that value. For that, what I will do is I can just specify the data type of this is date time. Date time is a data type. So just like an integer, date time is also one of the data type in SQL. When I specify a column is date time, I can store date along with the time in that particular column. Okay. So every time when I inserting the data in this table, I need to enter ID, order number, order date every time, right? But instead of providing this order date manually, I just provide only ID and order number every time. I will insert only ID and order number every time. But order date column should automatically populated by the current date and time. So order date column should be automatically populated with current date and time. I don't want to every time enter the date and time. So in that case, we can also specify some default constraint. So this is the exact scenario, guys. You can also specify some other columns and you can specify some default value. If you don't enter any value into the column, so default will be taken care of it. But here, this is exact scenario. So every time you don't enter date and time, and date and time automatically should add it to the column along with the ID and order number. So here I'll say default constraint. And what is now is returning is, now is nothing but it will return the current date and time. So we already discussed about built-in functions in MySQL. So now is a function, built-in function in MySQL, which will return the current date and time from SQL. So if you execute only now here, let me just select now. So if you execute this command, this will give you current date and time here. This is our current date and time. Now this particular column, every time whenever inserting a order ID and order number, by default I'm saying insert this value, whatever the value this function is returning, insert that value inside the order date column. That is a default value. Every time we'll enter the date and time automatically. Okay, default value, I'm entering that in the column. So that I'm saying here. So now let me create this table with a default constraint. Once you execute your default constraint, now the table is created. Now let us try to insert a values. How to insert a values? And let me show you here. So when say select now, what it is written. So this is written some date and time, right? So this value we can insert in the third column. Now I'll try to insert a value inside the orders table. Observe guys. Select the insert command, right? So insert into orders table, insert into orders, values. What is the first value? ID. SA101 is an ID. Order number. So order number is some number. Okay, order number, I'll give some number, comma, and order date, right? So order date, I will pass this value directly. And just copy this value and then put it here. And then semicolon. Right? So this is a valid statement because we are passing 3 columns. So here I'm passing manually. I'm passing this value manually. So when I insert this record, so the record is successfully inserted. Now, if you see this one, select star from orders, select star from orders. Now this will give you one record. So this record I have executed manually, I have inserted manually. But what I want to do is, I don't want to insert this value manually. I will insert only ID and order number, and this value automatically inserted by this function, now function. So in that case, how we can insert the data? So the second scenario, I'm going to insert only ID and order number. So insert into orders, and here I'll specify what are all columns only I'm inserting. So what are columns I'm inserting? ID and order number, ID and order number. So these are only 2 columns I'm going to insert. And now I'll say values, and here I'll say order number 102, and order ID is some number I give it. And now I'm not providing the third column. But instead, if you don't specify this one, it will throw an error, guys. So if you directly say insert into orders, values, but this is need 3 columns data. But here you are passing only 2 columns data, right? This will throw an error. So column does not match value count at row 1. Value count is not matched. It is having 3 columns, but you are passing data for only 2 columns. But in this case, it will not apply the default value, guys. Okay, default value will not apply. But we need to specify exactly what are the columns data we are updating. So insert into order, specify that value, order ID and order number. So now this will consider as order ID. This will consider order number. So we left the order date value. So in that order date column, this method, whatever now function is returning, that function return output will be added. By default will be added. So whenever I execute this, let me execute this. Now it is inserted now. So now execute this, select star from orders. Now it should have 2 records. So let me execute this one more time. It is failure, out of range value column order number. Okay. So this value is very huge. Let me just put short value. Okay. Now execute this. So now it is executed. So when I say select star from orders, now we can see the 2 records. So this order date value is always incrementing, right? So this is always updated. So we are getting updated value by using now function. So the third column value I have not passed. I just passed only ID and order number. And the third column value automatically updated because I have specified that column as a default. And what is the default value we need to update? Whatever the value now function is returning, that value is a default value for that particular column. If you want to pass intentionally some value, the value will be updated. Whatever value you have passed manually, that value will be updated. If you some case, if you don't want to pass that value, specify exact columns and data and leave that particular column, and that column will be filled with the default value. So this is how we need to use default constraint on the table. So any columns we can specify with some default value. And sometimes if you forgot the value to enter in that particular column, so default value will be updated. So that's all about default constraint. So these are all about constraints concept. So how many constraints we discussed? So we have 6 constraints: not null, unique, primary key, foreign key, check constraint, and finally default constraints. So these are all integrity constraints. We call as a integrity constraints in SQL. Okay. So integrity constraints are used to specify the rules on data in a table. We can apply certain rules on the data on a table. All right. So that is all about constraints concept.